biggest question is, should I use RAG or fine tune the model or train a LoRA? So these three terms are constantly compared as if they are three versions of the same thing. But no, there is a huge difference. And there is a one mistake I want to clear up immediately. LoRA is not really an alternative to fine tuning. LoRA is a way of fine tuning a model more efficient. So the real question is this: when should you retrieve information and when should you actually change the model? Let's use an example throughout this video. Imagine we are building an AI assistant for a research lab. We want it to answer questions about our papers, experiments, internal notes, and procedures. We also want it to really reply in a specific format and behave consistently. Start with the easiest option, that is prompting. If the model already knows enough and the only problem is that your instructions are vague, you probably do not need RAG or fine tuning at all. A better system prompt, a few examples, or a structured output may solve that problem. But suppose I ask, what did your team conclude in last week's experiment? A base model cannot know that. The information does not exist in its training data. This is where RAG makes sense. So basically RAG stands for Retrieval Augmented Generation. The keyword is retrieval. Your documents are stored outside the model. When a question or a prompt arrives, the system searches those documents, retrieve the most relevant pieces, and put them in the model context along with the question. So the pipeline looks roughly like this. Document go into an index, the user asks a question, the system retrieves relevant information, and that information is inserted to a LLM prompt before LLM generates an answer. The important part is what does not happen. The model weights are not being updated. If I added a new paper to the database today, I don't need to retrain the whole LLM. I only need that paper to become retrievable. That makes RAG especially useful for information that is private, frequently changing, too large to place in every prompt, or needs to be traceable back to a source. But RAG has its own failure mode. The LLM can only use information that your retrieval system actually gives it. If the wrong chunk is retrieved, the answer can still be wrong, even if the correct information exists somewhere in the database. This is why RAG quality depends upon one more than a language model, and that is chunking, embedding, search, how to find the correct metadata, and the amount of context you return. These things all matter. Now let's change the problem. Suppose the assistant has the right information, but every answer is badly formatted. Maybe we need to respond to follow a particular structure or a format, or perhaps we need the model to behave like a specialized classifier, follow domain-specific patterns, or consistently produce a type of output that prompting alone does not reliably enforce. Now we are moving forward towards something called fine-tuning. Fine-tuning means training the model further on examples that represents the behavior we want. So instead of giving model a document at query time, we are adjusting the weights of the model, the parameters of the model. For example, we might give it hundreds or thousands of input and the output pairs showing how questions should be answered, how a task should be performed, or what style and structure we want it to give us. This is fundamentally different intervention from RAG. RAG changes what information the model can see at the inference time. But remember, fine-tuning changes the model itself. The distinction is the easiest way to remember the difference. And this is also explain one of the most common mistake I am seeing right now. Trying to fine-tune an LLM just to make it know a set of documents. You can sometimes make model internalize information through additional training. But if those facts change very weak, fine-tuning is usually a poor database. Updating a retrieval system is much simpler than repeatedly retraining a model and hoping that it recalls the right fact. Now, where does the LoRA fits into this? A modern LLM contains billions and trillions of parameters. Full fine-tuning means updating a very large number of those billion and trillions of parameters during training, which requires a substantial GPU memory and compute. LoRA, or low-rank adaptation, takes a different approach. So instead of updating the large weight or like a billions or trillions of weight, we keep the base model frozen and learn a much simpler low-rank update. Visually, imagine that there is a huge matrix W inside the model. Full fine-tuning can modify the whole matrix W. With LoRA, we represent update using two much smaller matrix, often written as B times A, and that update to the original weight. So conceptually, W becomes W plus a small learned update that dramatically reduces the number of trainable parameters. This is why LoRA is often called parameter efficient fine-tuning. But notice what this means for the original comparison. So saying should I use fine-tuning or LoRA is a bit of like asking should I travel by a car or should I use an efficient type of car. LoRA is one method for doing fine-tuning. It does not solve a completely different category of problem the way RAG does. So now we can build a much clearer decision tree. First question: does the model need access to the information that changes? Is private or lives in external document? Yes, then start with the RAG. Second question: does the model already have the necessary information but behave incorrectly or inconsistently for your task? Then consider fine-tuning. Third question: do you want fine-tuning but do not want to update every parameter of a huge model? Then consider LoRA or another parameter-efficient fine-tuning method. And there is a fourth option as well that people generally forget. Use more than one of these together. Imagine our research assistant again. RAG can retrieve the latest paper and internal experiment. A LoRA adapter could make the model follow our lab's preferred answer format or perform a specialized task more consistently. The retrieve information is still external and up to the date, while the fine-tuning changes that behavior. Those two mechanisms are complementary. Here is the practical way I think about it. If the problem is knowledge access, think retrieval. If the problem is behavior, think of fine-tuning. But if the problem is the cost of fine-tuning, think parameter-efficient methods such as LoRA. And if the problem is simply bad instruction, fix the prompt before doing any of these. There are also trade-offs. RAG adds infrastructure. You need document processing, retrieval, and often evaluation whether the correct evidence was found. Fine-tuning adds a training pipeline. You need high-quality examples, GPUs, evaluation, and a way to avoid degrading capabilities you wanted to know. LoRA lowers the training burden, but it does not remove the need of the good data or good evaluation. None of these techniques magically fixes a poorly defined task. So if someone's tell you we trained our AI on our PDFs using RAG, that sentence is technically misleading. RAG is normally giving the model relevant part of those PDFs at inference time. It is not updating the model ways, remember that. And if someone says we choose LoRA instead of fine-tuning, the better description is that they choose LoRA as their fine-tuning method. Once you separate these ideas, the whole landscape becomes much easier to reason about. RAG changes the context, fine-tuning changes the model, LoRA changes the model efficiently. This is the distinction that I would remember. And in the next video, if you want, I can go much more deeper and show exactly what happens mathematically inside a LoRA layer and why a low rank update can adapt a model using only a fraction of trainable parameters.